Hi, I'm Gordon Cooper. I'm here with Fergus Casey. Fergus is one of our directors of R&D for IP processors. He's also our safety manager. So Synopsys now has an embedded vision processor, the EV6X, with a safety enhancement package, making it the first ASIL D ready embedded vision IP. So in the automotive space, functional safety is important. Where is embedded vision used in automobiles?
So we see our processor being used in deep learning algorithms within the embedded vision space, particularly on rear-facing cameras as well as front-facing cameras. But also our IP is used in vector DSP type areas such as radar and LiDAR.
Great. So with these use cases in the automotive space, why is ASIL D important for processor IP?
So ISO 26262 defines the automotive safety standard for electronic devices. And really, the ISO 26262 sets the various levels of safety integrity from ASIL B through to D, where ASIL D is the highest level of safety. It outlines the probability of exposure, the controllability of the driver, as well as the severity of failure. So really it's taking into consideration the safety of the driver with respect to the electronic devices within the component. For example, if you look at a lane departure system, for autonomous vehicles where lane departure could result in the driver dying, the highest level of safety is required, ASIL D. But for a driver assist type capabilities, ASIL B could be sufficient for that same system where the driver is aware, he's watching, and can take control of the car at any point in time.
So what is the difficulty of adding ASIL D to hardware IP? I mean, if it was easy, all processors would be ASIL D.
So that's a good question, Gordon. There are many hurdles and gates to pass before we can declare our IP ASIL D ready. It's more than a documentation exercise where the benefit of the 26262 is that it provides the metrics that we need to achieve to allow us to declare our processor IP ASIL D ready. So from the early phase of development, our processor architects will sit with the safety architects and outline a plan from a safety perspective to achieve the ASIL metrics required. So early in development phase, defining and agreeing on the safety features within the processor, collaborating those features against the processor architecture to confirm that no performance impact occurs, and that we still have a product that we can sell from a power area optimization perspective. So once we have the features defined, we'll then take those features into our FMEDA report, failure mode error detect analysis, and we'll run a qualitative analysis to determine that, hey, with these safety features, we can achieve the required ASIL level. Once we have a qualitative analysis completed, that we have an architecture that will achieve the ASIL level, we then move into implementation phase. Implementation, verification, validation. In those areas, we're pulling in the various Synopsys groups from a verification to the implementation to allow us demonstrate and validate that our assertions in the FMEDA report have been met once we get to the quantitative analysis. Once we're at the quantitative analysis phase, we now have an FMEDA report. We run our fault injection campaign, demonstrate that the analysis is accurate, and then we're at a point where we can present that back to our safety certifiers.
So it sounds like there's a lot involved, obviously, in this step. Is there anything else you want to add that Synopsys does to make it easy for a customer to get to certification?
So we work hand in hand with our customer from the IP evaluation perspective through to safety deep dive, IP selection. Even after the customer has purchased our IP, our safety teams will engage with that customer on a regular basis. Safety manager to safety manager, agreeing on what the safety requirements are, aligning that with what the safety IP that we provide meets those requirements. Our safety manager works closely and broadly across the Synopsys ecosystem to pull in the required safety expert within Synopsys, taking the customer from architecture phase through to implementation, verification, validation, and sign-off.
Great. Wow. So if somebody is looking at this from a design point of view and says, oh, I need vision in my automotive design and I want ASIL B, C, or D, how do they get started? What's the first step of the implementation process for them?
So we kick off a parallel evaluation. As is standard with any IP, the application team on the customer side will engage with our R&D or our application engineers to determine if the processor IP that we have is a right fit for their application. So typically, we'll run through the standard performance, power, area benchmarks, application benchmarks from the CNN graph perspective, and any vision algorithms that need to be ported to our processors.
Thank you. This has been great. So for more information on our EV6X embedded vision processors with Safety Enhancement Package, visit our website at synopsys.com. Thank you.